Hi, and welcome to the third of 3 videos for section 3.5. In video 1, first thing I did was introduce you guys to complex numbers, the topic of this section. And we talked about how I is equal to the square root of -1. So now that we have that sort of tool in our math tool bag, we can now deal with square roots of negative numbers. We have the following, that if r is positive, then the square root of negative r, so if r is positive, that means what? This is the square root of a negative number. Well, by our radical rules, this is the same as what? This is the same as square root of -1 times square root of r. We know that square root of -1 from video 1 is I, so this becomes the square root of r, and I'm going to put I in the front. The reason I put I in the front is if I was to write this like this, the question is that I under the radical or not? You know, maybe I drew this a little bit longer, so I can't really tell. Is it underneath of it? Maybe it isn't. If I put the I in front, confusion is gone. So if you have a radical, move the I to the front. If it turns into an integer, then you can just use, you can put it at the end, so 3i or 5i, like we had when we were doing in the last couple of videos. But if we have a radical left over, so if I have I times the square root of 3, I'm going to put the I in front rather than saying square root of 3i, because I'm not really sure if it is underneath the radical or not. Let's look at a couple examples. What if I have the square root of -16? Well, this is what? This is the square root of -1 times the square root of 16. The square root of 16 is 4. So this becomes I times 4, which I can rewrite it in the order then 4i, because I don't have that radical symbol showing confusion. And as I kind of gave as a random example, if I have square root of -3, well again, this is square, and you don't have to do this breakdown all the time, I'm just showing you now how it turns into this value with the I. The more of these you'll do, you just be like, oh, I comes out and here's what's left over. We have what? -1 times square root of 3. So this is I times the square root of 3. Square root of 3 doesn't simplify, so we just leave it. And then a third example. So if I have square root of -16 times the square root of -4. So our radical rules don't hold here where I can just say, oh, multiply what's underneath, -16 times -4, so okay, that's +64, so my answer is just 8. In this case, because we have a negative number, our radical rules don't hold here. So we have to do each of these separate. Square root of -16 is what? Well, square root of 16 is 4, and because of the negative, this guy simplifies to 4i. This one, square root of 4 is 2. Because of the negative inside, that's an I, so this becomes 2i. So this square root of -16 times square root of -4 is the same as 4i times 2i, which is what? This is 8i squared. And my I squared is what? This is equal to -1. So therefore, this is 8 times -1, which is -8. So you could have used, if you would have used our radical rules, negative times negative gives you positive, so you would have, oh, square root of 64, so it's +8, but it's not. It's -8 because we have to account for these values of I. So that's when we just have a straightforward radical. How do we deal with it if we're using this value of I and taking square roots? Finally, we're going to look at complex solutions of quadratic equations. So, on exam 1, I gave you guys a quadratic equation, said solve for x. In those cases, you were able to factor or able to use the quadratic formula, simplified it, got to an answer. The same thing holds here. The only difference is we're not going to be able to factor it really, so we're going to have to use the quadratic equation. So recall the quadratic equation is what? It's negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So if I have the following example, I want to solve x squared plus 4x plus 5 equals 0. Well, I can't factor this, right? Because 5 has only factors of 5 and 1, and because it's positive, I can't factor it in any way that's going to get me to a 4x. So if I use the quadratic formula, my a is 1, my b is positive 4, my c is positive 5. So I'll tell you now, you're going to need to know how to do this on exam 2, probably exam 3, probably the final. So make sure you know how to do these complex solutions of quadratic equation. If I plug these into the formula, I get what? I get negative b, so negative 4, plus or minus the square root of b squared, so 4 squared, minus 4 times a, which is 1, times c, which is 5, all over 2 times a, which is 1. Simplify this, what do we get? We get negative 4 plus or minus the square root. 4 squared is 16. Negative 4 times 1 is negative 4 times 5 is negative 20. All over 2. This is what? Negative 4 plus or minus the square root. 16 minus 20 is negative 4. All over 2. Square root of negative 4 is what? So square root of 4 is 2. Because of the negative, that's our I. So this becomes negative 4 plus or minus 2i over 2. So if we split this up, it's negative 4 over 2 plus or minus 2 over 2i. So if I simplify this, negative 4 over 2 is negative 2 plus or minus 2 divided by 2 is 1. So my final answer is negative 2 plus or minus I. So this is a complex solution to a quadratic equation. And that's really it. It's the same as you've been doing before. The only difference is you get a negative under the radical. So we need to use the idea of the imaginary unit I to get rid of the radical and simplify from there. So that's it. That's the end of video 3. Come on back and we'll look at section 3.7. We'll look at 3.7.